Hello, let's learn about association and causation. But first, let's remind ourselves of some background knowledge. The word correlation. Correlation is the tendency for two values, which we usually see as variables, to change together. They can either move the same way, positive, or in opposite ways, negative. With positive, as one thing gets bigger, the other thing gets bigger. With negative, as one thing gets bigger, the other gets smaller. The other option is to have no correlation at all, meaning there are no tendencies for them to move in the same way. Now, association is a set of data with two or more variables. In algebra, more than likely, we're only going to have two. Association is two things happening simultaneously. That means at the same time. This guarantees that there is an association, okay? Two things happening at the same time means there is association. It does not, however, mean that there is a correlation, meaning both of them are changing the same way or that they are changing in opposite ways. It also means there's not necessarily a causation, and you probably don't know this word because I haven't gone over it yet, so hold on. Example. If you go to the grocery store and you see the price of eggs and you see the price of cheese, well, they're both existing in the grocery store right now, so there is an association. However, the price of eggs does not affect the price of cheese. So if the price of eggs goes up, doesn't necessarily mean that the price of cheese will go up. It also does not mean that the price of cheese will go down. I have no idea what will happen. But they do exist in the same time, in the same place, so there is an association. All right, here's the word, causation. Let's say it together, causation. Good, it's like the word cause. Kind of cool, huh? When the change in one quantity or one variable causes the other to change, that's when we have causation. Couple important things about causation. First, it must be scientifically proven that one thing causes the other. Can't just be that sometimes or it kind of looks that way. You should be able to create an experiment and scientifically prove that one causes the other to happen. Like it's not coincidence. It causes this to happen. Now, if there is causation and one causes the other, then we can decide which one is independent, the causer, or dependent, the one that's being affected. And 3, just because we have a positive or negative correlation, meaning just because they both change the same way or because they change in opposite ways, that doesn't mean that there's causation. There is still association. They are happening at the same time, but we don't necessarily have causation just because we have a positive or negative correlation. Here's an example. The amount of time you spend eating chips and the amount of calories you consume. You guys see my typo right there? Wah, wah. Well, eating more chips causes you to take in more calories. That will always happen. So there's association because you have the time that you're eating chips and how many calories that you're consuming. Those are our two things. There's a positive correlation because the more time you spend eating chips, the more calories you're going to put inside your body. And finally, there is causation because the more chips you eat causes you to have more calories inside your body. Okay? That is scientifically proven. In fact, it's true for all food. The more time you spend eating food, it puts more calories in your body. So that is causation. All right, you try. I'm going to give you an example. You decide if there's a correlation, so positive, negative, or none. You decide if there's association, yes or no. And you decide if there's causation, yes or no. Ready? Here we go. The amount of gas in the tank of your car and the number of miles you can drive. What do you think? All right. There is a correlation, okay, and it's positive because the more gas you have in the tank allows you to drive more miles. Association. Well, yeah, because there's two things, gas and miles. So there's association. Causation. Yes, because the amount of gas affects your ability to drive miles. So if you don't have enough gas, you're not going to be able to drive as many miles. All right, so let's try another one. Wait, miss, that's the same one. No, it's not. Read carefully. The amount of gas in the tank of your car and the number of miles you drive. Wait, how's that different from the other one? This one says the number of miles you can drive. This one says the number of miles that you do drive, or that you drive. Well, will that change our answers? There's still a positive correlation. The more gas in your car, the more likely you are to drive. Now notice I said more likely. A correlation does not mean that your gas causes you to drive. It just means that, yeah, if you have more gas in the tank, you are more likely to drive more miles. Association. Yes, there's two things, gas and miles. Causation. No. The amount of gas does not cause you to physically drive. Could I have a car sitting in my driveway or at my apartment complex and it's full of gas and I never drive it? Sure. Having gas does not make me go drive my car. Okay, so the previous question talked about my ability to drive. Can I drive miles? Sure. This one is, am I actually going to go drive it? Well, I don't know, maybe I don't feel like driving. Okay, so causation, one causes the other to happen or not. So here's a review. Correlation. This is whether or not things change in the same or opposite ways. Association, two things happening at the same time. Causation, one thing actually causes the other to happen. Causation is really hard to prove. Really, really hard to prove. Because you have to have a scientific experiment to be able to back that up. Not that we're actually going to go do the experiments, right? But you have to be able to think about it in that way. All right, guys, move it on out.